Hello everybody. So today I will talk about calculus. The topic today is about application of integrals and derivative. So now I will show you how to answer. Here is about the figure in here. Here is about the table. And this one is about introductions. We have the juice is sold in 20 centimeter tall bottles with horizontal cross sections parallel to the base that are circles. That means if I choose about one location in here, we will create about the cross section, and this cross section that's about the circle, and the radius of the circular cross section at height h above the base of the bottle is given by a differentiable function r. So that means we have the height in here, and we know that each value on this one we can able to do first derivative of the function in here, and where h and rh are measured in centimeters. Selected values of rh are given in the table above. Here is about the table. Question A. Approximate first derivative of the function r at h equal to 3.1 using the average rate of return of r over the interval from 0 to 6.2. Show the computations that lead to your answer. So they always ask you use about the units of measure. The formula of this one, that should be about r of b minus r of a over b minus a. So we need to use about two numbers in here. This is about b, this is about a. So b, that's about this one, a, that's about this one. So b is about 6.2. So we have 6.2 in here, and r of b that's about 2.7. So we put about r of 6.2 in here minus r of number 0 over 6.2 minus 0. So about this one, that is about r of 6.2, you got about 2.7 in here minus r of number 0, that's about 2.5. So we calculate about this one, and we have 0.032, and that's about centimeters in here. And this is the answer for question number 1. Question B. Interpret the meaning of 1 over 20, the interval from 0 to number 20, and we have the function in here in the context of the problem. So if we look carefully about this one, we have 1 over 20, that's about 1 over 20 minus 0 in here, and we have the integration from 0 to number 20. That means if we put like this, this is about the average. And the formula of the average, that should be like this: 1 over b minus a, and we have the integration from a to b, and we have f of t dt. So in this context, they want to find about the average of this one. So they want to find the area of this unit in here. Then they divide by 20 from 0 to number 20. So they just find the area in the average of this one. Now let's go to the next one. Use a trapezoidal sum with the 3 subintervals. So we have 3 subintervals in here. So in this one, we have 3 subintervals in here. For example, I choose about 6.2 in here, and number 13, and number 20 in here. So the question they use about trapezoid, that means from 0 in here, we need to find the area of 3 trapezoids. Here is about the trapezoids in here, and we know that this is about the right angles. We need to find the area of this one. To do about the trapezoids, we need to know that we need to find the height of each unit. So this is about the difference between from 0 to 6.2 in here. And from 6.2 we have number 13 and number 20. So this one we can calculate about the different two numbers in here, similar for this one and this one. So in this situation, we can find the approximation of the interval from 0 to number 20, or h. The h, that should be about, we have the height in here, the value of number 0, that's about 2.5. The value of this one in here, that's about 2.7. Multiply by this one, the difference between 6.2 minus number 0 in here, over number 2. So we just find the area of one location in here. Now let's go to the second one. We do the same. So that should be about 2.7 in here, plus the value of number in here, that's about 4.3. And then the difference between number 13 and 6.2, we divide by 2. And the last one, so we have 4.3 and 2.6. And we have 20 minus 13. So we sum all three fractions in here. You got about 64.07. Now they want to find the value of this one, so we just divide by number 20. You got about 3.2035 centimeters. Now let's go to question C. The radius of the circular cross section at height h above the base of the bottle can also be modeled by the function f. So here is about this one. From 0 to number 20, based on the model at a height of h equals to 12 centimeters in the radius increasing or decreasing as h increase. So they want to apply about application of derivative. So we have the function in here. Now we need to find first the derivative of this function. So we have number 3 and we have the fractions in here. So we have number 2 with the square root of 2 minus 1.25, and we have cosine of b over 100 h minus 20 square. So later that we do first the derivative of this one in here on numerator. So this one we will have about 1.25, and we have number 2 because we have the power 2 in here, and we do first the derivative inside in here. So we have 2b over 100 h minus 20, and then we have sine of b over 100 h minus 20 square in here. Because first the derivative of number 2, this is about the constant, so you got about 0 in here. First the derivative of cosine, you got about negative sine, that's why we have another negative in here. Negative with negative, you got about positive. 1.25 we put in here, and this is about the sine after we do first the derivative. Inside of cosine we still have about b over 100 and h minus 20 square. So we do first the derivative of h minus 20 square in here. You got about number 2 h minus 20. Later that we do first the derivative of h minus 20, and you got about number 1. That's why we just simplify like this. Now we need to put first the derivative of the function equals to number 0. So we just have only this one and this one can equals to number 0. So I need to simplify like this. So we need to find about the critical points That's why we need to put first the derivative of the function equals to number 0 in here. So we will have about h minus 20 equals to number 0. So h equals to number 20. And the next one, this one equals to number 0. So we will have about b over 100 and h minus number 20 square equals to kb. So we know that k should belong to integers. So we simplify b for the both sides, and we put 100 go to the right. Now we need to put the square root for the both sides. So we have h minus number 20 equal to 10 with the square root of k. And h minus number 20 equals to negative number 10 with the square root of k. And then we put negative number 20 go to the right. So we have number 20 plus 10 with the square root of k. And h equals to number 20 minus 10 with the square root of k. So in this situation, k should be about the positive number. So we need to put about z with the positive. So the smallest of k in this situation, that's about number 0. So if we put number 0 on here, we will have about h equals to number 20, 20. When k equals to number 1, so we can find the value of h in here. So this one you got about 30. This one we have number 10, because we need to find the value of h between from 0 and number 20. So this one we just have only number 10 in here. And the next one, when k equals to number 2, so we will have about h equals to 34.14 and h equals to 5.8. 5.6, 5.86. So if k equal to number 3, we don't have any value in here, because the value in here, this is greater than number 20, and the value in here, if we put k equal to number 3, you got about the negative. And now we can create about variation table. So we have the function in here, and we have first the derivative of the function. So because we have from 0 to number 20, so variation table should start from 0 to number 20 in here. And now we can put about the critical points. So the first one we have 5.86. The next one, that's about number 10. Sorry, I just missing about one value in here. So when we put k equal to number 3, we put number 3 in here, and we got about h equals to 2.68. So we have 2.68 in here. So this one you got about 0, 0, 0, and 0. Now the next one, we need to put one value between number 10 and number 20. Go in here. And we see that this is about the negative. Now we put the value between number 10 and 5.86. And this one we put in here. And you got about positive and so on in here. So we see that the question they want to, based on the model of the height of h equals to number 12. So number 12 is in here. We see that at number 12, first derivative of number 12 in here is about negative, because we have the negative sign here. If the function is negative with first derivative, that means at location f of number 12, when h increase, the radius will be decreased. So that means for this one, that should be about decreased, because first derivative is about the negative. So the answer for this one we need to choose, that's about decreasing. And the last one, using the model f defined in part C, find the volume of the bottle. So we have the function in here, and we have the bounds in here. So we can find the volume of this one. This is the formula to find the volume. So we have this function in here, and we know we have the square root, and we have number 3 in here. If we put the power 2, you got about number 9 multiplied by this one under the square root. So I will copy this one in here. Now we need to find this one. Number 9 multiplied by number 2, you got about 18. Number 9 multiplied by this one, we have 11.25 cosine of b over 100. So the integration of this one, that is so simple. So we will have about 18h, and we have the bounds from 0 to number 20. But for this one, we don't have the formula for h minus number 20 to the power of 2. So we can use about the technology to calculate about this one. We have b in here because we have b multiplied by this one in here. So for the first one, we have 360b. And for the second one, you got about 39.43b. So we use this number minus this number. So we have 320 57b, and this is approximate about 1007.1, and we have square centimeters. And this is the final answer. This is the end. Thank you for watching.